Right now, somewhere in the walls of the room you're sitting in, there are copper wires carrying electricity to every socket, every switch, every light. Under the street outside, copper pipes carry water. Under the ocean floors, copper cables carry the internet, the actual physical cables that connect continents and make the global internet possible. Inside every smartphone, every laptop, every electric car motor, every solar panel, every wind turbine, copper. It is the metal that makes the modern world function, not gold, not titanium, not steel, copper. And here is the thing that should genuinely surprise you. The average home contains roughly 100 kilograms of copper. A single Boeing 747 contains around 180 kilometers of copper wire. One electric car uses 4 times more copper than a petrol car. As the world electrifies, solar, wind, electric vehicles, smart grids, the demand for copper is set to double within the next 20 years. So how do we get it? From green-stained rock in a mine to the wire in your wall. Let's open the file. Copper is the oldest metal ever worked by human hands. The earliest confirmed evidence of copper use dates to around 8,700 BC. Copper beads found in a cave in modern-day Iraq. That is more than 10,000 years ago, long before writing, long before the wheel, long before agriculture had even properly begun. Why copper? Because like gold, it occasionally appears in its native pure form in nature, small nuggets of actual copper metal lying on the ground or in riverbeds, ready to be picked up and hammered into shape without any smelting needed. Early humans found copper and discovered it could be shaped into tools, jewelry, and weapons without fire. Then, around 5000 BC, humans discovered that if you heat copper ore in a fire, you can extract far larger quantities of metal. Smelting was born. This was one of the most transformative technological discoveries in all of human history. Around 3300 BC, someone, somewhere in the Middle East or perhaps Cyprus, discovered that mixing copper with a small amount of tin produced something far harder and more useful than either metal alone: bronze. That discovery launched the Bronze Age, a period that reshaped human civilization across Europe, Asia, and the Middle East. For over 2,000 years, the island of Cyprus was so associated with copper in the ancient world that the Roman word for copper, cuprum, was derived directly from the Latin name for Cyprus. That is where the chemical symbol Cu comes from. Today, copper's defining property is no longer its hardness. It is its extraordinary electrical and thermal conductivity, second only to silver among common metals. That makes it the indispensable backbone of the modern electrical world. Step 1. Find the copper and crush it. Modern copper ore typically contains less than 1% copper by weight. In some of the world's largest mines, the ore grade is as low as 0.4%. That means you need to mine and process 250 tons of rock to get 1 ton of copper metal. The world's largest copper mines are in Chile and Peru. The Escondida mine in Chile's Atacama Desert alone produces about 5% of the world's entire copper supply. The greenish color of copper-bearing rock, from minerals like malachite and chalcopyrite, helps geologists identify deposits from the surface and even from satellite imagery. The ore is blasted from open pit mines, loaded into enormous haul trucks, and transported to crushing facilities. Step 2. Froth flotation, separating copper from everything else. The ore slurry is pumped into large flotation tanks. Special chemical reagents are added that make the copper mineral particles hydrophobic, water-repelling. Air is then pumped through the bottom of the tank, creating millions of tiny bubbles. Here is where the clever chemistry happens. The hydrophobic copper particles attach themselves to the air bubbles and rise to the surface with the froth, while the worthless waste rock, called gangue, stays behind in the water and sinks. The copper-rich froth is simmed off the surface and collected. What you get is a copper concentrate, a thick, dark powder containing between 20 and 30% copper. That might not sound like much, but remember, you started with 0.4%. You have already multiplied the copper content by up to 75 times through this one process. The concentrate is filtered, dried, and sent to the smelter. The waste tailings, the gangue left behind, are pumped into large containment ponds. Managing those tailings safely is one of the copper industry's biggest environmental challenges. Step 3. Into the furnace, smelting to blister copper. The dried copper concentrate is fed into a high-temperature smelting furnace. Modern operations use flash smelting furnaces that inject the fine concentrate with oxygen-enriched air, creating an intensely efficient combustion at temperatures exceeding 1,200 degrees Celsius. Inside the furnace, the sulfur and iron in the concentrate oxidize and separate. What settles at the bottom is called copper matte, a molten mixture of copper and sulfide that contains around 60% copper. The slag, containing iron and other impurities, floats on top and is drawn off separately. The copper matte is then transferred to a converter furnace, where compressed air or oxygen is blown through it. This burns off the remaining sulfur and iron. What emerges is called blister copper. Named for the blistered surface it develops as sulfur dioxide gas escapes during cooling. Blister copper is approximately 98 to 99% pure. It looks nothing like the gleaming copper you know. It is a rough, lumpy, yellowish-brown casting, but it is almost there. Step 4. Electrolytic refining. The process that creates 99.99% pure copper. The blister copper is cast into large, flat slabs called anodes, each one roughly a meter square, 2 inches thick, and weighing around 340 kilograms. These anodes are suspended in large tanks filled with an electrolyte solution of copper sulfate and sulfuric acid. Thin sheets of pure copper, called starter cathodes, are hung in between the anodes. When an electric current is applied, copper dissolves from the anode and deposits atom by atom onto the cathode. The critical detail: only copper dissolves and redeposits cleanly. All the impurities, gold, silver, platinum, arsenic, lead, either stay in the electrolyte solution or drop to the bottom of the tank as a sludge called anode slime. After 14 days of continuous electrolysis, the starter cathodes have grown into large copper sheets weighing around 160 kilograms each and containing 99.99% pure copper. These copper cathodes are the finished product. 5 facts about copper that will change how you see the world around you. Fact 1. Copper kills bacteria. A surface made of pure copper will kill 99.9% of bacteria within 2 hours, including E. coli, MRSA, and influenza. This property is called the oligodynamic effect, and it is why copper door handles in hospitals reduce the spread of infection. Some hospitals have replaced all their door handles, bed rails, and light switches with copper. It is a living metal that actively fights disease. Fact 2. The Statue of Liberty is made of copper, 31 tons of it. When it was installed in 1886, it was a shiny reddish-orange color, exactly like a new penny. The green color it has today, called patina or verdigris, developed over decades as the copper reacted with oxygen, water, and salt air. The Statue of Liberty has been turning green for over 130 years and will continue doing so for thousands more. Fact 3. The world currently recycles about 35% of all copper produced, a higher rate than almost any other industrial metal, and recycled copper is just as pure and functional as newly mined copper, requiring only 15% of the energy. Some copper pipes in Roman aqueducts installed over 2,000 years ago have been excavated and found to still be functional. Copper does not degrade. Fact 4. We may be running out of easy copper. The grade of copper ore being mined today is roughly half what it was in 1900. Mines are going deeper, processing more rock per ton of copper, consuming more energy and water. As electric vehicles and renewable energy accelerate, the demand for copper is projected to exceed supply within the next decade unless major new deposits are found. Fact 5. From a copper bead in a cave in Iraq 10,000 years ago, to the wire inside your wall, the pipe under your street, the motor in your electric car, and the cable beneath the ocean carrying the internet. The oldest metal ever used by humans is also the most essential metal for the future of human civilization. Not gold, not titanium, copper. And it all begins with green-stained rock in an open pit mine in the Chilean desert. Ground to powder, floated in a tank, smelted at 1,200 degrees, and purified atom by atom over 14 days of electrolysis until it is purer than almost anything else on Earth. Every object has a case. Every material has a story. We'll see you in the next file. The Object Files. Every object has a case.